Okay, so what we're going to start today, and we will finish next time you're in class, is we are going to look more at conditional probability. So we've already looked at the basics of conditional probability, and that is the probability of A given B is equal to the probability of A. If the events are independent. That's not what I meant to say. So that's if the events are independent. Probability of A given B in general, and this is on your formula sheet, is the probability of A and B over the probability of B. What you've seen for the most part so far is probabilities from a table or the Venn diagrams. There's one last kind of probability that is the toughest one, and it involves using a tree diagram. So that's what we're going to talk about today. We are going to do one example together, and that is probably all we will have time for. If you could find this page, please. Shannon hits the snooze bar on her alarm clock on 60% of school days. If she doesn't hit snooze, there is a 0.9 probability she will make it to class on time. However, if she does hit snooze, there is only a 0.7 probability that she makes it to class on time. Use a tree diagram to represent the situation. Okay. It is very important that you define variables and that you can write this information in probability notation before you do anything else. So there are only two things happening here. I'm going to use S to be she hits snooze. And then I'm going to use T to be she's on time to class. Okay, so it says she hits snooze on 60% of school days. So the probability of hitting snooze is 0.6. If she doesn't hit snooze, that's a conditional probability. So that is given she doesn't hit snooze. So that's S complement. That's not S. There's a 0.9 probability she makes it to class on time. So she makes it on time. That is 0.9. If she hits snooze, so that is given she hits snooze, she makes it to class on time is 0.7. Okay, so now we need to use a tree diagram. In your tree diagram, the first branches are always going to be the single probability. So we're going to start with this one right here. So every day, either she hits snooze or she doesn't. So this one option will be she hits snooze. The other one will be she doesn't hit snooze. She hits snooze 60% of the time, which means she doesn't hit snooze 40% of the time. After that, after she hits snooze or she doesn't, either she's on time or she isn't. So if she hits snooze, either she's on time to school or she's late. Because we know she hit snooze, this is going to be the probability given snooze. Probability given snooze. So then either she's on time or she's not. But both of them are given snooze because we already hit the snooze. And then we know the probability of T given S, that one's right here, that's 0.7, which means the other probability is 0.3. So then if she doesn't hit snooze, again, either she's on time or she's not. So similar idea, except this time it's given she didn't hit snooze, or given she didn't hit snooze. Either she's on time or she's late. And again, we should know one of those. T given S complement, we know, is 0.9. Which means this one is 0.1. So if we go to part B, on a randomly chosen day, what is the probability that she is late for class? So we are looking for the probability that she is not on time. Okay, we don't have a lot of probabilities that would be helpful here. There are only two probabilities that have late, that have T complement. It's this probability right here and this one right here. So if we think maybe we want to use one of those conditionals, if I try to take a look at this one and see if it's helpful to me. So the probability of T complement given S complement, if I use a conditional formula, that will be the probability of T complement and S complement over the probability of S complement. So do we see that that isn't going to help us find T complement? Right. So then if we were to use this one, that's not going to help us find T complement either. It will help us find S. So what we currently have is not helpful yet. The key to the tree is we add on some probabilities here. We can see from this formula right here, if I put this probability over 1 and I cross multiply, that if I take that conditional and I multiply by that given probability, it gives me an AND. So what I'm saying is if I multiply these two numbers, I get an AND probability. So this would be the probability of T complement and S complement. And that would just be 0.04. So likewise, the one right above it, this would be T and S complement. And again, I'm just multiplying 0.4, 0.9, so I get 0.36.
I kind of lost track. It suddenly went with a lot of numbers, a lot of formulas very quickly.
Okay, so here's what we're doing. I'm taking this number, multiplying by this number, so I get 0.42. And what that gives me, whatever this conditional is, it's the same variables, but an AND probability. So then, same variables, it'll turn into an AND, and I multiply the numbers beforehand. And we will use those in a minute. What I want you to notice is that all four of these numbers sum to 1. So these two sum to 1, these two sum to 1, these two sum to 1, and then at the very end, everything sums to 1. So then the question is, how is that helpful? Because we have to keep in mind what we care about is how often is she late to class? Well, here's where all of this then gets put together. If she's late to class, one of two things happened. Either she's late to class and she hit snooze, or she's late to class and she didn't hit snooze. There's no other option. If she's late to class and she hit snooze, or she's not late to class and she didn't hit snooze. Those two numbers can be found from the table. So this first one, T complement and S, is right up here. It's that 0.18. The T complement and S complement is right here. It's that 0.04. So then the probability that she's not late is 0.22 when we add those two numbers up. Part C. Suppose that Shannon is late for school. What is the probability that she hit snooze? Okay, this is a conditional. Given she's not on time. what is the probability she hits snooze? Now, I would like to point out that S given T complement and T complement given S are different.
Yes.
This one is, she hits snooze, this is given she's late. So this is a conditional. Now we're just going to use the conditional formula. So this is the probability of S and T complement over the probability of T complement. T complement we just calculated. It's that 0.22. And then this S and T complement is the same as T complement and S. And the order doesn't matter. So we're using that 0.18. So that gives us about 0.82. How would we interpret that probability?
Something along the lines of if she's late, it is this amount likely that she hits snooze.
Okay, something
The
along
wording-
those lines.
The wording will definitely be better, but I think
Yes.
that's the gist of it.
Okay, anybody? Come on, guys. Give me something. Thank you.
In the long run, roughly 82% of the time that she's late for school, she's
Okay. Thank you. In the long run, if we look at many days when Shannon is late, on about 82% of those days, she hit snooze. What I would be looking for is many days. I need two more things to write down. We are going to do another one of these next class. So right now I just need you to write this down. General multiplication rule. If we take the conditional, what the general multiplication rule does is it solves for the and the and is just the conditional multiplied by the probability of the given. So all it is doing is rewriting this one. The general multiplication rule is not on the formula sheet because it's just a version of the conditional probability. And then last thing I want us to know is we need to know when to use a tree diagram. So I told you in part A, use a tree diagram. I'm not going to in the future though. So you need to recognize when a tree is appropriate. A tree is appropriate when events are sequential, like she hits snooze and then she's on time. Sequential or conditional. Okay, next class, we're going to do more tree diagrams.